Exclusions and limitations. This novel approach to targeting requires careful consideration of the ways in which individuals can be incorrectly excluded from receiving program benefits. Methods, program exclusions. Our analysis highlights 6 main sources of exclusion errors for the expansion of Novacy. Table 2. 1. Beneficiaries must have a SIM card to access to a mobile phone. Field survey data from 2018 to 2019 indicate that 65% of adults and 85% of households have a phone. See also supplementary figure 3. 2. They must have used their SIM card recently in order to generate a poverty score between 72% and 97% of program registrants. 3. They must be a registered voter, roughly 87% of adults. 4. They must self-target and attempt to register, roughly 40% of eligible individuals attempted. 5. They must succeed in registering, which requires basic reading and digital literacy. 72% succeeded. And 6. They must be successfully identified as eligible by the machine learning algorithm. 47% recall. Table 1. Many of these sources of possible exclusion overlap. Extended data table 5 thus estimates, on the basis of the 2020 phone survey, the extent to which each successive step in registration creates additional exclusions. These results highlight the fact that algorithmic targeting errors are an important source of program exclusion, but that real-world programs also face structural and environmental constraints to inclusion. More broadly, our analysis shows how non-traditional big data and machine learning can improve the targeting of humanitarian assistance. Beyond the gains in targeting performance, a key advantage of this approach is that it can be deployed quickly and responsibly. In Togo, the government's objective was to deliver benefits to the poorest people in the country. So our efforts focused on training a machine learning model to target the poor. In other settings, such as following natural disasters, the people most impacted by adverse events may not be the poorest. With high-frequency phone data available in near real time, related techniques might be used to more dynamically prioritize the people with the greatest need. For example, it may be possible to train a machine learning algorithm to identify people whose consumption fell by the greatest amount based on changes in patterns of phone use following a crisis. Another possibility would be to simply use location information from mobile phone data to prioritize people who are likely to live in impacted regions. Methods: location-based targeting. It is important to emphasize that our phone-based approach is far from perfect and may lead to important errors of both exclusion and inclusion. There are also practical limitations to this approach, for instance, regarding data access and privacy. Several such considerations are addressed in supplementary discussion, section 2. Moreover, our results do not imply that mobile phone based targeting should replace traditional approaches reliant on proxy means tests or community-based targeting. Rather, these methods provide a rapid and cost-effective supplement that may be most useful in crises settings or in contexts where traditional data sources are incomplete or out of date. We believe that future work should explore how real-time data sources, such as the phone data used by Novacy, can be most combined with more traditional field-based measurements so that these complementary data sources can be best integrated in the design of inclusive systems for social protection.